Welcome to the session. Greeting of the day. In today's class, we are going to see about the various pneumatic actuating systems. We have seen in previous classes that in the actuating drive mechanisms, drive or actuating systems, we have divided into electrical actuating, mechanical actuating, then hydraulic actuating, and then now we are dividing into the pneumatic actuating systems. Now we are going to see about this pneumatic actuating systems and their few types. We have seen about the general filters, compressors, reservoir tank, control valves, and then the actuating mechanism of a piston. And then with respect to that also we have seen about this various types of compressors, such as this various piston compressors, double compressors and multi-stage compressors, and diaphragm, screw. Those things we have seen. You see now the pump, the various types of compressor we have done. This part we have already seen at the first beginning of this compressor pneumatic systems. What are they? Let us split out the few points. The air treatment and the pressure regulations. At start, the large sized particles are prevented from the entering to the compressor by the intake filter. This image we have seen at the beginning, the filters, compressors, then the separators, then the tank, control valve, and the actuating system. Likewise we have seen. Here also the same, I am elaborating the same few points there. See? First, primary air treatment to be done, then we come to the secondary air treatment. Here in this setup you see, what are the points I have told earlier, the same filters, separators, dryers will be there. So inlet filter, first I am taking the filter, it is coming inside. From the filter, the impurities are filtered out. Then I am coming to the compressor, it is stored, and the volume reduction, temperature increase, this we know. Therefore from here, it again is to be cooled, then dried if required, then the reservoir tank, and the air service secondary treatment also done for the secondary filtrations, and then coming to the load. So here the loading action, here the control valves will be there. First, before reservoir I am calling as a primary air treatment, maybe this second after reservoir I am calling this as a secondary air treatment. Temperature of the compressed air is lowered as using the coolers. So using the coolers, here the temperature of the air which is formed due to the compression on the compressor, the temperature has been removed by the coolers, the heat exchangers. Secondary air treatment, further filtering. The further filtering is carried out. Maybe if required, little bit of lubrication to avoid the frictional contacts. We can lightly, smoothly, lubrication can be added in the air. It means lightly moistured. First we are drying out. We don't know how much it is moisture level. And later for lubrication purpose, this moisture level will increase the corrosion rate. That lubrication level will reduce the friction rate. So for those purpose we can able to do this addition of a few smooth lubricants, little percentages. Lubricants introduced in a fine mist of oil into the compressed air. Here it is compressed air. After when it is coming compressed air going to the operation, actuating mechanisms or control valves, you should move. You should face the surfaces of the control valve. The air should face the surfaces of the cylinders and pistons and loads. Their friction should not be the issue. For that purpose, I am adding this lubricants in the secondary air treatments. filters. One by one we will see. So this filters and then dryers, little bit we will elaborate. To prevent any damage of the compressor, yes, it contaminates present in the air needed to be filtered out. Dry or wet filters can be done. Dry filters uses the disposal cartridges. In the wet filters, the incoming of the air passes through the oil bath and then through the fine wire of meshing filters. First we are going for the oil bath also. In such a way, dust particles will be mixed with the oil and can be removed. And then later, if required, fine wire meshing, close contact like a mosque. So close contact like, and then we are filtering from the meshed filters. So such things are done. Next I am coming to the cooler. So we have seen about this filters, compressors we know. Now I am seeing the cooler. To prevent any damage, coolers, the cooling of the composed air, it is cooling the compressed air. The type of heat, it is one type of, we may call it as a heat exchanger because it is removing and passing the other one as in the compressed form, temperature removed separately. Two type of coolers commonly employed are air cooled and water cooled. So one is, here it is water cooled and one is the air cooled mechanism. So here how we can do, so here the passage will be there, so it is a passage will be there, and then here we have a heat exchangers and is going to take, after taking it can be lightly modified into a cooled one. Such cases are transferred. Maybe this may be the air force air transfer, heat exchanger due to air or heat exchanger due to water circulations. Mainline filters, some type of filters used to remove the water vapor or solid contaminants present. So air filter and water tapping can be done. Air filtering and water trapping can be done. Whatever available, the waters are not needed, it is going to corrode. We need lubrications only. Lubrication can be added. Water to be trapped out and air to be filtered from the dust particles and impurities. Those things are done here. See, the air is taking the inlet here, and then here the buffer is doing the job. Keep on pressing and action and cooling. This vibrations makes the impinging action between the air that contains the airs and dust particles, impurities, and the condensed mist water also is drained out. And finally, what happens? The smooth air, it lifts out. It's going to lift out through these filters. Here also I have placed some filters. In such a way, dust particles can move. Comes here and it can move through the air outlet. Very simple mechanism using the buffers. So prevent the solid contaminations. The filters can able to, any dust particles are there, any solid obstacles are there, it can be obstacled by this filters and bubbles. Condense and remove water vapors. Remove the water vapors. The dry air is coming out now. The dry air is coming out from the filter. Then if required, we can add the lubrications. So refrigerations and dryers. It means nothing but a separator. The cooler, the filter, we have filtered now. Dust particles and compressed. It may be hot now. Now it is to be done heat exchanging process. How I am doing? I'm doing two-stage heat exchanging process. A simple two-stage heat exchanger I am using. So the misted air I'm getting in. Here itself, one heat exchanger is kept. When it is coming down, here also one way heat exchanger is kept. I'm increasing, I'm reducing, more trapping process I'm doing. So multiple I'm doing, therefore it comes again here, and again it goes through this path and dried air. So it is a dry air. It is a moistured air. Here it is come. So likewise, a cooler is wetted air is going to dried out, and the dried out air we are taking out. So nothing but a dryer. Lubricator. Now what we need, it is dried out. Filtered, temperature to increased by the compressor. Then the temperature is taken out by the drying actions or refrigeration heat exchanging actions. And now the dryer is ready to move. But this air may cause the frictional contact between the cylindrical piston action forces on the control valves. So I want a few fine lubricants there. So therefore, to form a mist of oil on the air to provide a lubricants to the mating components. Mating components is a cylinder. So here friction to avoid the frictions. To avoid frictions. So likewise. So how I am doing? Here the inlet is there. The inlet is coming. I am supplying a lubricating oil mist at the center nozzle. Through that nozzle, the air is going to pass through and going to take the exit inside the component, inside the machine setup. So it is taking, it have to cross over the oil mist. Then the air will receive fine mist particles, the air will contain the fine oil mist. So what happens? It comes here with the oil now. Here it is dry air. Here it is misted air, and it comes in. And if it is any other water particles or any other is there, it can able to oil reservoirs, more air it is there, more mist is, more oil has been absorbed by the air. It can be again has been done, and then it is through the buffers, through the buffer vibration actions, it can again doing. So again it is going outside. It is the outlet. We have taken. So we have some check valves here. It is recirculating. It is recirculating. Mist, oil coming down, air is taking the fine, and it goes out. So such actions can be done to increase the lubricant to avoid the friction. So such actions. So relief valve. We have seen about this relief valve, how the direction of the flow will happen. Some of the like a control valve, which the direction to be A direction. So likewise the control valves, whether it is A to be moved or B to be moved. Such actions we have to do. In this setup, the air source of pressure, it comes in the pressurized air comes in. Here we have a control valves. So this can able to push the spring return. The spring return setting I have kept. So that when the pressure is applied, this spring has to move in the upward direction. Therefore, it can take the pressurized air can take exit through the available outlets. This is one available outlet, and this is one available outlet. You can take exit. So this is the same part we have seen in the pump also, hydraulic system also, hydraulic control valve, a puppet valve, ball-ended valves. So such cases are also available for air treatments. So maybe the air, maybe the hydraulic systems. So setup is common, right? So this is about the relief valve. When it will be relief, why I am naming this a relief valve? Here maybe we have, let us consider a compressor is here. We are having the filter having, and then it is stored here, compressor here, it is keep on filling. Air is filled now. Air is exceeding the limit of the compression of the cylinder, of the relief or of the reservoir tank. There we have the relief valve in such a way it can able to push this high pressure only possible to push this spring return. Otherwise the spring return is going to keep on the force here. If the force pressure is 10 bar, if the pressure reservoir's tank's pressure is 12 bar, then it will keep the increase. If the reservoir's pressure is 9 bar, it won't. Therefore, we need a pressure greater than 10 bar. According to the springs written, spring force has been applied here. Spring force has been applied here. When the force is exceeding, it is going to push out. Therefore, the pressurized air can take the exit. It can relieve from the reservoir tank. That is why it is named as a relief valve. Non-relieving pressure regulators. You see, when the action, similar action of inlet has been occurred, and I am threading action, adjusting screw I am using. Adjusting screw. I need a little slow exit. And I need a large exit of pressure. Then I am able to allow this permittable limit. I am allowing here small. When the screw is again threaded towards the downward direction, the more cavity has been created, more holes are generated, therefore more flow can be takes place. So such cases are fine. What happens here, you see, here we have a diaphragm. When more flow occurs, the opening is more, when more flow occurs, the diaphragm automatically, by the spring return action, it goes to push up. If it is pushed up, what happens here? This will be closed. Therefore, the flow won't be there. Specifically, I need one amount of flow rate. When the pressure is increased, relief should be stopped there. If the pressure increases, it is going to push the diaphragm. Diaphragm is pushed, the wall also is going to, along with the spring, it is going to push up. Then it is going to stop the force and it will stop there. When the outlet is went, there will be no force on the diaphragm, therefore again it comes down, again the air can be flowed back. So the diaphragm is used for multiple actions, to stop, to on the flow. So that is why it is named as a non-relieving pressure regulator. If the pressure exceeds, relieving is not to be done. It moves up and it stops. It is terminated. Excitation is terminated. Here it is terminated. When the pressure is low, again it comes down, normally it flows. For safety purpose, safety valves. So the service units, I am calling this as a secondary service units. What are we are doing? We have already seen this. I am giving a name. Filtration, regulation and lubrications. We have did this. Filtration we have did. Separation of heat exchangers we have did. And if needed after dry out, we have did the lubrications also. Here the impurities are removed. Here temperature is removed. Here lubrication oil is added. So such actions are done. So I am calling this all this together as a service unit. So here separator, pressure regulator, lubricators. So something I am regulating some pressures, temperatures and pressures. Pressure increase or decrease. So whatever it is. So I am calling this as a total service units. Just I am identifying. Actuators. Now I am coming to the last one. Output devices which convert the energy from the pressurized compressed air, oil or air or oil into the required type of action or motion. We want to move this. We want to move this piston, that is important. Up to now we have talked only about these filters, these compressors, these dryers, these service units, this control valve. From here each should be connected and the air should come inside and it should push here in such a way load will be moved here. This is to be moved finally. The actuating mechanism we are seeing. We name here. So that is why this converting of energy of a pressurized air or oil we are using. From that it is to be moved to the required level of action. Whether it's to be moved 10 mm, it's to be moved 20 mm, whatever it is. So linear actuators, rotary actuators, or otherwise the flow control actuators are there to move linearly at a rotation side otherwise the control off on-off switches. So such actions. For that I am dividing a single acting cylinder. Single acting cylinder, this we have already, even though we have seen the hydraulic systems. Produce work in one direction of motion. Only it flows in one direction motion. The compressed air pushed the piston located in the cylinder bar, causing the desired motion. So I have taken this. This is the single acting cylinder, and the air to be inlet given. Therefore, it is going to push and it is going to move. That is what this one. See, the piston is available here, and then I have to give the pushing action to the fluid or the air. Fluid or air should come in this direction. So the fluid has to come here. Fluid has to come here, and it pushes the piston. The piston will have to move in the other direction. So it is a single acting cylinder. Next I am coming to the double acting cylinder. What it does? The single acting cylinder operated through the spring return. How it comes back? We have made this. When the same, this is one action. This is one action. Single acting cylinder. Now I want to make a second reaction. I want to push it back. It means coming to the original position. So I want to give an inlet here. The secondary input has to be given in such a way this air keeps going. This is the double acting. Now I am not giving this. I am not giving this. Instead of that, what I am doing, I am adding the spring here. I am adding a spring here. So this spring will be helpful. Spring will be helpful when the pneumatic air is stopped here. Automatically the force will not be there. Therefore the spring force will cause the pistons to come back. Single acting. Now the same I am doing here as a double acting. What I am doing, both first action and return action are operated through the pneumatic or hydraulic operation itself. How? You see here there are two conditions are there. One at the inlet, one at the outlet. So what I am doing, the main part of piston rod, cylinder tube and the end caps. Yes, the parts are verified. The piston's rod connected to the piston head and other end extends out to the cylinder. The piston divides the cylinder into two chambers. This is important. This is one chamber, chamber 1, and this is chamber 2. Two chambers I have divided. So what happens here? Namely, the rod end sides and piston end side. The rod end side and piston end side. Just the operating side and pushing side. Likewise, the seal prevents the leakage of the oil between those two chambers. The cylindrical tube is fitted with the end caps. The preserved oil air enters the cylinder channel. Now you see, I am giving the inlet in this path. Let us consider, I am giving the inlet in this path. It is going to push there. Therefore what happens? The piston have to move in this direction. Right? We have taken the output here, we have the object here. We have the object here, it has been pushed. Stage 1, forward action, over. Now, this operated piston should come back. In the single acting cylinder, what happened? We have kept the spring return. We have kept the spring return. Here the spring return is there. So the spring return, due to when this air is terminated, obviously the force is not there in the forward direction. Therefore, the spring force causes the piston to move back. But here, I am giving the force. I am giving the force in this direction now. The secondary direction I am giving here. Secondary direction is given. So this force makes this piston to move when this is not given. And therefore what happens? The fluid, somehow it is present here, will take exit back to the same position to the reservoir. Here also one reservoir is there. So here, from here we have taken in. Otherwise, the same reservoir can be connected to what? At the background. So what is our understanding? The fluid flows through this, fluid or air flows through this one direction, piston moves. One stage. After double, one completed. And when the fluid or air comes in another direction, it is going to move when it is not in action. It's to be terminated and then only this flow can come back. I am pressing that side, I am pressuring this side, both are same. The piston won't move. So this is how our understanding can be made for double acting cylinders. Now cylinder end cushion. What happens when the more force is given? There is a chance of damaging of this cylinder. Therefore, what I am given here, a little bit small cushion I am giving. This is the cushion. So this is the cushion I am giving. So see, so this is the cushion I can able to use. This one, the Cushing plunger. The Cushing plunger I can able to use this. So this is the cushion. Piston is operated here. Piston is operated here, the large one. The pressure has been given here. And then the other end we are operating some action. What is the action? The fluid port, this is to move here. It is to turn some other actions that takes place. I have a cushion to operate slowly to avoid damage of the piston with respect to huge sealing, huge impact will not be generated. So that is all done by the cushion efforts. Contain a cylinder cushion at the end of the cylinder. Cushion of the end cylinder to slow down the movement. So this is important. Slow down the movement of the piston near the end of the stroke. At the last, force to be minimized. So cushion arrangement avoids the damage due to impact occurred. The cushion avoids the damage due to impact occurred when the fast moving piston is stopped by the end caps. So this is how we are using this cylindrical end cushion in the double acting or single acting cylinders. So the summary. In today's class we have seen about the various types of pneumatic systems. In pneumatic systems, the types of compressors and the types of control valves and also the filters, heat exchangers, the lubricators, and this system, the service systems. So the connections we have seen. The remaining part of the subject we'll see you in the next session. Thank you.